Hi everyone and welcome to Chapter 8, Sec 3E Mathematics, Arc Length, Area of Sector and Radian Measure e-learning. For this particular e-learning, we'll only be focusing on 8.1 and 8.2. 8.1 teaches us how to find the length of an arc. And what we will be learning is to define the different parts of the circle and to express the arc length as a fraction of the circumference of the circle. But before we go there, I need to introduce to you the different parts of the circle. Now you notice that this circle is actually divided into two by this line PQ. This line has a very special name known as a chord. Length PQ is known as a chord. It is a straight line that joins 2 points of the circle. Okay, so you can anyhow draw a chord here or a chord here. A chord is basically a line that joins any 2 points on the circle. How about these curved lines over here, PRQ and PSQ? They are known as this thing called arcs, ARCS arcs. Both lines are actually part of the circumference. Length PSQ is known as the major arc because it is longer, and length PRQ is known as the minor arc because it is shorter. Now you will notice that the chord PQ actually also divides the circle into two different areas. And what are these two different areas called? They are known as segment. A segment is enclosed by any chord that you draw and an arc. It is not difficult to see that the bigger area here, enclosed by PQ and PSQ, is known as the major segment. And the area enclosed by PQ and PRQ is known as the minor segment because it is smaller. Are there any other ways to divide the circle up? Yes, there are, and you will see this in the next example. Okay, these two areas over here are known as sectors. A sector is not enclosed by one line and one arc. It is enclosed by two lines and one arc. It is enclosed by two radii or two radiuses and an arc. It is not difficult to see that because this is the bigger sector. This is known as the major sector, and since this is the smaller sector here, the part enclosed by PRQ, OP and OQ, this is known as the minor sector. So before we move on, I want you to try out the checkpoint questions that I have posted on your worksheet to actually check whether you understand the difference between a sector, a segment, between the chord and the radius. Okay, so please spend some time doing it and your teacher will go through it with you in class. Okay, so let's move on to the next main part of this e-learning, which is to find out what exactly is the arc length. Now, to find out this, we are going to make use of a knowledge that we know of earlier, which is to find the circumference of the circle. And you would know that the circumference of a circle can be found by this formula 2 pi r, or pi times diameter. So let's take a look at this example over here. How do I find the arc length over here, ASB? Now the arc length basically just represents a fraction of the circumference. I'm trying to find this length over here. This length is known as the arc length. If you have guessed it right, yes, indeed, we need to make use of this angle with respect to the whole angle around the circle, which is 360 degrees, in order to find out the fraction of this part to the whole circumference. So upon calculation, I will know that the ratio is 45 degrees over 360 degrees. And to find the arc length, I simply multiply it to the whole circumference of the circle. Why? Because this ratio over here represents a fraction of the whole circle. And this arc length over here tells me the fraction of the corresponding fraction of the circumference this arc length is. What happens if now my angle changes to 90 degrees? Now, most of you would obviously know that ASB would actually be 1/4 of the whole circle, right? But how do you get 1/4? Think about it. How would you make use of this angle? Okay, for most of you who might know, how we got 1/4 is 90 divided by 360 degrees. Remember, we are using this angle as a fraction of the whole, which is 360 degrees, which will give us 1/4. And so to find the corresponding arc length, I just take this fraction over here, 90 over 360, multiply it by the whole circumference to get this. And if I simplify it, I get pi r over 2. Okay, it is not hard to see that even for this 60 degrees example, it's just 60 over 360 equals to 1 over 6. And to find the corresponding arc length, I just take 60 divided by 360, multiplied by the whole circumference to get pi r over 3. Now, what happens if I have an angle which is more than 180 degrees but less than 360 degrees? Now, just to recap, these angles are called reflex angles. Similarly, to find the arc length ASB, I just take the ratio of 260 over 360, which is equals to 13 over 18, and to find the arc length, I just take this value, multiply it to the circumference to get this. So from our investigation, you can see that if I have a circle whose angle at the center is x degrees, to find the arc length, all I have to do is to find out the fraction that this arc length is as part of the whole circumference by using this angle, and I would find that this fraction is x degrees over 360 degrees, and to find this arc length, I simply multiply it by 2 pi r, which is the circumference of the circle. So I hope this gives you a better understanding on how to find the arc length using angles. In the next few examples, we will learn how to apply this formula. So I'll see you there. Thank you.